Last week we worked a good bit with understanding that when you divide and there are decimals involved, if you want to continue after a whole number, you can put a decimal, put the zeros, and you bring the decimal right up into the answer. There are some other places that decimals can appear in division problems. So what we're going to do today, we're going to look at all of the different varieties of places that decimals can appear in division problems. We will talk about what to do, and as the week goes on, then we'll discuss more about why that makes sense. So today, this is just what you do when you see decimals in the division problem from the very beginning. One thing that's very important is to look where the decimals are. If the decimal is only in the dividend, we've already practiced this. You bring the decimal straight up into the answer and you continue dividing like normal. This, if the problem looked just like this would be exactly like we practiced last week, except instead of putting zeros after the decimal, there are already digits in the tenths and hundredths place, so you would divide through with them. Then, if needed, you would put more zeros in the thousandth, the 10,000th, and so forth. But it's different when there is a decimal in the divisor. So remember, this is the divisor because you got your little guy here. His visor is over his head. There's his face underneath his hat. Here, he has his feet. Now, those feet are going to be important with this because what he wants to do is he needs to be able to kick this ball. If you think of your decimal like a soccer ball, he needs to be able to kick this ball. So it needs to be right next to him. So you have to move this decimal to the right of any digits that there are. In this case, the soccer ball only takes one hop. Now you'll notice also there's a soccer ball in here. Well, he's going to use this leg. This soccer ball must move exactly the same number of places that the one did on the outside. So if we stop calling this a soccer ball and we talk about it as the decimal now, which mathematically it is, what that means mathematically is if there's a decimal in the divisor, you must move it so that you get a whole number. You have to keep track of how many places you move the decimal in the divisor. However many places the decimal in the divisor is moved to the right, you also need to move the decimal that many places in the dividend. It's like they're hooked together. Whatever you do to one, you must do to the other. Once the decimal is here, we don't really care about that in the division part. What we care about is where the decimal is in the answer. So this problem, you would divide through by the 47. 7 times 6 comes close to 47. 6 times 7 is 42. You subtract, you get the 5. You bring down the 7. 7 times 8 is 56. And you subtract. Now, remember, I've told you you don't want to mix decimals and remainders. I've told you 5th graders, you must go at least 2 places past the decimal, so you would put another 0 here so that you could go 2 places past the decimal. 7 times what comes close to 10? 7 times 1, which is 7. You subtract, you get a 3. You do not report this as a remainder. The directions tell you round your answer to the nearest whole number anyway. So this gives you enough information to round. Your final answer here would be, is it 6 or is it 7? Well, it would be 7. I don't want to focus right now on the long division part, but I did want to show you if you're doing the division and you get 2 places past the decimal and there is still a remainder, when there's a decimal, sometimes the directions will tell you to round. Sometimes you would want to go back and check to see if you made any mistakes, if you still had a remainder there. Otherwise, you would keep on going. Remember, we're focusing on what to do with the decimals. I don't really care to look first in the dividend for a decimal. I look in the divisor. There is a decimal in the divisor. The decimal must always be right next to the bracket there when you're dividing. So you really want to turn this into 17. However many places you move this decimal, you must also move this decimal in the same direction. It doesn't stop here. We're really interested in getting it into the answer. So when you did this problem, you would do this problem as 58 divided by 17, how many whole times it goes in, and then you would have to extend it afterwards, and you'd round to the nearest whole number. Number 3, this one I am going to do with you for a couple of reasons, because if it's dividing by 2, I know it will end. And after last week, you should be starting to figure out why it would end. But first, there is a decimal in the divisor. I must move that decimal so it is next to the bracket, so I have a whole number. I just moved it 1 place, so I only need to move this decimal 1 place and bring it immediately up into the answer. One way of looking at this is udging the decimal, sort of playing with the word nudge. When you nudge something, you move it a little bit. You get the word udging the decimal, the idea of udging it, because this looks like a U and this looks like a J. So if there's a decimal when you divide, you need to udge the decimal from the divisor. I almost called it the dividend. That's why I caught myself. I did say I would divide this. 6 divided by 2, I can do this, so I begin right here. It's important to place the number right above where I'm dividing. Why? Because I will also need to divide by the 5, and I'll need a place after the decimal. 3 times 2 is 6. Subtract, get a 0. Bring down the 5. 2 times what comes close to 5? 2 times 2, right? So the 2 goes as close to the 5 as I can get it. 2 times 2 is 4. Subtract and get a 1. Can't have a remainder. When you are past the decimal, which you are, there are as many zeros as you need. In this case, you only need 1, because 5 times 2 equals 10. There is no remainder. 32.5. It does ask to round to the nearest whole number, so really what they're after for that answer is 33. Udge the decimal because it's in the divisor. I udge it just 1 place here, and it's by the bracket, so I only udge it 1 place there. So I will have 3 whole number places before I get into the decimal. 4 times what comes close to 7? That's just 1. 1 times 4 is 4. Subtract, get a 3. Bring down the 7. 9 times 4 is 36. Subtract, get a 1. Bring down the 6. 4 times 4 is 16. Subtract, 0. Bring down the 4. 1 times 4 is 4. This is the exact answer. If it were to be rounded to the whole number, they would only want 194. But this one ended with exactly the digits they gave you. But it is important to see this is 194 and 1/10. Number 5, do we need to udge the decimal? Yep. How many places? Just one. Since this decimal must move the same number of places, you udge it right up into the answer. 3 times 2 is 6. Subtract, get a 0. Bring down a 0. 2 times what comes close to 0? I must do something with this 0 because I just brought it down. I have to show 2 times nothing. Nothing times 2 is nothing. Subtract. Bring down the 8. Now I'll be on the tenths side of the decimal because of udging it. 2 times 4 is 8. This one I'm just going to show you how to udge the decimal. How many times do you have to udge it to get it next to the bracket? See how all these others, we only had to move the decimal one place and it was right by the bracket? If we only udge the decimal once, it's not beside the bracket yet. We don't have a whole number on the outside. We must udge it twice. Uh-oh. I only have one place I can udge it on the inside, but I'm supposed to udge it 2. If I do udge it 2 and bring it up into the decimal, or into the answer, sorry, I don't have anything in that place. That's right. You don't have anything in that place. You put the 0. You must have placeholder zeros. So let me erase this and show it to you again so that you can see what happened here. We udge the decimal 2 places here. We must udge it 2, but there's nothing in that second place, so I have to show there was nothing there before I brought the decimal past it. What happens if it looks like this? If the decimal is anywhere outside the bracket in the divisor, you must always udge it. But what happens when you can't see any decimals on the inside? Well, these are whole numbers. This decimal is where it belongs. This is where it starts in a whole number. I have to move it one place and bring it up, just like we did with this one. When there was nothing in the place that I had to move it, I show nothing. This one moves once. This has to move once. Where is it? It doesn't show it to me. Oh, wait a minute. It's a whole number. I must move it one more place. What do I do to fill in that place? Put a 0. Udge this decimal just once. It starts here in a whole number. Udge it over. What do I do to show there was nothing in that place? You put nothing. Udge it once. Whole number. It didn't show us a decimal anywhere else, so it must be at the end of the whole number. I need to move it once into the answer, so I put a 0. This one, udge it once. Whole number, it starts out right at the end after the ones place. I have to move it one more place. What was there? Nothing. This one needs to move not once because it's not next to the bracket yet. It needs to be udged twice. So the decimal starts at the end of the whole number. It needs to be moved not once. Once would have only gotten it here. It needs to be moved twice. There was still nothing in both of those places. Once it's been udged, bring it right up into the answer. And a mixed one. There is a decimal in the divisor, so I must move it until it's next to the bracket. I just udge it once. So I udge this one. I don't need to do anything fancy. I just move it one place. There are digits there. So the decimal comes right up here. There is no decimal in this divisor. Do I need to udge this? No. So where will the decimal be in the answer? Right there. There is a decimal in the divisor. I must udge this decimal. Oh, wait. Where is a decimal for me to udge on the inside? Because if I udge the divisor, I must udge the dividend. Oh, wait. There it is. But there was nothing in this place. Good. There still is nothing in that place. Do I need to udge this decimal? No, because there's no decimal in the divisor. The decimal is already next to the bracket if it's not shown to us. I do need to include this decimal in the answer. What about here? Ooh, I need to udge this decimal right next to the bracket. So I must udge this decimal right up into the answer. How many places will I udge? Not just once. That doesn't get it next to the bracket. Udge it twice. Where's the decimal here? Well, if you start it here, that doesn't show a whole number. If you put it here, that shows 7 whole things, but 4 parts. You must start the decimal at the end of the 74, because it's 74 whole. If you only udge it once, that's not enough. Udge it twice. What do you need to fill into both of these places to show there was nothing there and there still is nothing? There we go. Bring the decimal up into the quotient and extend your bracket. That is the process. As we go along this week, we will talk about why you do the process that way. But remember, it's only if there's a decimal in the divisor that you udge. If there's no decimal to start with in the divisor, but there is a decimal in the dividend, bring it right straight up. Once you have your decimals placed, all of the rest of the division work goes exactly the same.